So here we got a rate law type problem here. So this should hopefully be fresh in our heads, and hopefully we remember how to do these. But if not, here we go. I want to find the rate expression / rate law and the value for k for the above reaction. So we've got 2a plus 3b yields 4c. Doing rate laws, we ignore the coefficients out in front. We only deal with coefficients when we're dealing with equilibrium constants. So I want to find two experiments. We'll call this experiment number 1, experiment number 2, and experiment number 3. I want to find two trials or two experiments where only one of these substances changes, whether it's just A or B. So if I look at experiment number 1, I have 0.1 molar of A and 0.3 molar of B. In experiment 2, I've got 0.3 molar of A and 0.3 molar of B. So if we look at experiment at A changed from 0.1 to 0.3 when going from experiment 1 to experiment 2. But B didn't change at all. So by looking at experiment 1 and 2, it'll tell us how changing the concentration of A will affect our rates. So we're going to look at this expression here. Rate is equal to K times the concentration of A raised to some exponent we'll call M times the concentration of B raised to some exponent N. And I know that my rate of experiment 1 over rate of experiment, actually we'll do 2 over 1. The math will work out the same, but I always like to put the bigger rates above the smaller rates. Just makes me more comfortable. But anyway, and then we'll look at the concentration of A from experiment number 2 over the concentration of A from experiment number 1 raised to the m power. So I'm going to take 2.25 times 10 to the negative second over 2.50 times 10 to the negative third. And that's going to give us 9, and that's going to equal 0.300 over 0.100 raised to the m. So that's going to equal 3 raised to the m. 3 raised to what will give you 9? Well, that gives us 2. 3 squared will give us 9. So we know that m is 2. We're going to do the same thing. This time we're going to look at experiments number 2 and 3. Because in experiment 2 and 3, only the concentration of B changes. Right? So concentration of A stays the same, concentration of B changes. So any difference in my rates are going to be because of my different concentrations of B. So we'll do rate 3 over rate 2 is equal to the concentration of B from experiment number 3 over the concentration of B from experiment number 2 raised to some number n. So we're going to do 2.25 over times 10 to the negative second, over 2.25 times 10 to the negative second. We're going to equal, set that equal to 0.600 over 0.300. That's going to give us 1. This will give us 2. 2 raised to what will give you 1? Well, anything raised to the 0 power will give you 1. So n is equal to 0. So now I've got my values for n. I can n to m. So we can erase those exponents and we can put some real numbers in there. I've got a 2 there and I've got a 0 there. So now I want to find the value for k for this. So I'm going to kind of bring this rate expression up here just for some room. So I've got rate is equal to k times the concentration of A squared times the concentration of B to the 0 power. I'm going to rearrange this to get k by itself. So k is equal to rate over A squared. B squared, or B to the 0 power, will always give us 1. So it really doesn't matter what this is going to be. So I really don't even need to bring that down there. So now let's just choose any of these 3 experiments to plug our numbers in. Doesn't matter which one we do. We're going to get the same answer for this. So I'm just going to choose the first experiment. So my rate in the first experiment, so the rate is going to be 2.50 times 10 to the negative third over 0.100 squared times 0.300 raised to the 0 power. And if I do the math, I should end up with k as being 0.25 big M to the negative first seconds to the negative first. That looks like a 2 seconds to the negative first. Anyway, that's my value for k. So now I've got everything I need in order to do letter B. So what would my rate be if my concentrations of A were 0.8 and my concentration of B were 1.0? So I'm just going to plug it into the equation that we just came up with. Rate is equal to K, which we said was 0.25 big M to the negative first, seconds to the negative first, times 0.800 big M squared times 0.100, I'm sorry, that is 1.00. 1.00 big M raised to the 0 power. I plug that into the calculator, and it should spit out 1.6 times 10 to the negative first, and that's going to be the units I have up here, either moles per liter per second or molarity per second. And that's how that problem's done.